Hi, I'm Stephen Sami. So I'm starting the part one. Explain any one of the following digital encoding scheme with example and typical application. I'm doing the N or ZL, the non-return to zero level encoding scheme. So Zn or ZL transmit all data bits value of ones as zero voltages and all zeros as positive integers. As positive voltages. So NOZL encoding scheme are found in networking switches and telephone communication systems. So NOZL is used for short distances between terminal and modem or terminal and computer. So now I'm going to use an example of it. Like here we got 8 bits values different. We got 1 0 1 1 1 0 0 1. So like I said, when the started with the binary value 1, so the voltage goes down to the 0 level voltages, and like here the voltages is 0, so it brings it up again to the positive voltages, and like here we got 3 consecutive 1, so the voltages will be down again but stays on the same level, on the 0 level voltage, because there's 3 consecutive 1, and will bring up again because it changes from 1 to 0 and stays on the positive level of voltages because it's followed by another 0 here, and like here it's a 1, so it just bring it down. So another figure here is another example is like we got 8 bits value like 1 0 0 0 1 0 1 1. So like in the previous example, when we start with the 1, the voltage just we bring it down to the 0 level, and it comes up because there's a followed by a binary value of 0, so it comes up with a positive voltages and stays on the same level because it's followed by 2 more zeros, and then we bring it down to the 0 level because there's a 1 here, and it comes up again because it's followed by 0 here, and it's continues like this with like 1 here. We just bring it down again and it stays flat because we got another 1 here. Now explain any one of the following multiplexing technique with example and typical application. So I'm doing the frequency division multiplexing. No, sorry, I'm doing the time division multiplexing. Time division multiplexing of a medium involves the dividing the available transmission time on a medium among users. There's two forms of time division multiplexing, that is synchronous and statistical time division multiplexing. The synchronous time division multiplexing accepts input from a fixed number of devices and transmit their data in an unending repetitious pattern. Two forms of the synchronous time division multiplexing is a synchronous optical network and the synchronous digital hierarchy telephone system. The other form of time division multiplexing is a statistical time division multiplexing. It accepts input from a set of devices that transmit data by creating a frame with data and information, and then it transmits that frame. An example is when utilizing the time division multiplexing, it includes digitally transmitting several telephone conversation over the same copper wire cable or fiber optical cable in a time division multiplexing telephone network. Now, the other part, explain any one of the following concept with example and typical application. So I'm doing the lossy compression technique versus a lossless compression technique. So compression, first of all, is a process that compacts data into a smaller package of a communication line. So there is two types of compression, the lossy and the lossless type. The lossless data compression is when data is uncompressed. The original data remains the same, and in a lossy data compression is when the original data is lost during compression and decompression stages. An example of the lossless compression include Huffman codes, run length compression, Lempel-Ziv compression, and the free lossless audio codec. Example of lossy compression is MPEG, which is the Motion Picture Experts Group, the JPEG, Joint Photographic Expert Group, and the MP3. So, in a lossless compression, the run length compression technique replaces runs of zeros binary value with a count of how many zeros binary value we have. Run length encoding replaces each decimal value with a 4-bit binary value, which is called enable. So let's say in a situation where we have to code a value larger than 15, so we need two consecutive 4-bit enables. So in a lossy compression, audio and video file do not compress well using lossless technique. Audio compression is compressed for MP3 players found in phones and other media devices. We are now moving to the part 2, the virtual network. So my task is to a virtual network installed to operating system in the virtual box and using my installation to display you the bridge NAT internal network and how this network represent a home or small home or business network. So bridge networking connects a virtual machine to a network using the host computer's Ethernet adapter. In bridge networking, TCP/IP network virtual machine needs its own IP address. Whereas in NATing, that means network address translation, it gives a virtual machine access to network resources using host computer's IP address. If NAT is selected, virtual machine can use many standard TCP/IP protocols to connect to other machines on the external network. Example, we can then use HTTP to browse websites and FTP to transfer files. So, network address translation allows a workstation inside a network to translate its private address to a public address. The main use of NAT is to limit the number of public address inside an organization. Private address best fits for networking devices in an organization that needs to access like file servers, printers, or when you're using in an intranet. So with network address translation, a router translates the private addresses to public IP addresses so that the network devices in an organization can access the internet. We have the internal networking, which are guest systems that have being connected to the same internal network, which will be able to communicate with each other in the network internal network configuration. Communication with the host system or another network outside the virtual box will not be possible. So now I'm going to show you on the virtual box here, like on the we got two operating system. We got the Windows 7 and Ubuntu. So let's say I have to configure the network adapter for Windows 7. So like here, the adapter 1, I enable two adapter. So the first one I use NAT. So like here, there's NAT bridge adapter, which I explained earlier, and the internal network also. So this is where I can configure and can change it to a different protocol here. So here, like the net adapter 2, I'm using the host only adapter, and same for the Ubuntu as well. And let's go to network, like here's NAT bridge internal network, NAT, and NAT adapter, bridge adapter, and I use the host only adapter for the second one. So like if on Windows 7, let's say like this is a small connection, this network represent like a small home business network, because like here I got my computer that's connect to a multiple network through a virtual box, and which I get access to the internet. And also I can connect to I got a file server which I can connect to, say here. The file server is on the Ubuntu machine, which, so let me just open the terminal, checking the IP. So like here we have the 192.168.56.115. so this is the IP of the server, and here I'm going to connect to the server. I'm going to connect to this it's here. So prompting me for authentication. Like here, this is a server, so this is a directory of the server, and this is Ubuntu. I'm trying to link the file server which is installed on the Ubuntu system to the Windows operating file here. Let's say I come here on the Windows 7. I'm accessing the FTP server from the Ubuntu operating system, and here it's asking me for credential. So this is definitely a small business, a home business network. Like here I got the directory of the server, same exactly. Let's say here, say this is like here, this is a Ubuntu, and he is a file server with the directory, and here is a Windows 7 client machine, which I'm connecting to the file server using this IP. And here's a directory which is the same here like on the file server. Yes. And this network only like comprises of a it's not a big complex network infrastructure. We're just sharing the file within two operating system, and we are connected over like a router, and we're using the NAT to transfer our private address to the outside world, to the public address, so that the um, mm, so that we can get internet access. Like if we say okay, go, so the NAT is being translated to the public address, so that's where why we can have internet access on the Windows 7. And like the Ubuntu here also, we trying to have access on the internet. Linux. So sure, we having access on Linux too, having internet access. So this will be described like a small business, home business network. So now we are back now to ping each operating system. So it's a Windows 7 operating system, and we use the IP config to display the both adapter. This is the adapter with the NAT. This adapter uses a host network, and like here the IP is 192.168.56.110. This is on the Windows 7 operating system. Now we are moving to the Ubuntu one. So like here we use a ifconfig to display the both adapters IP address. So like here, this one is a NAT one 10.0.2.15 that uses the same IP address, same private IP address, which is found on the Windows Server NAT adapter too. So this one is the host only network, which has the different IP address 192.168.56.115. This is for the Ubuntu one. And I'm trying to ping now the IP address of the Windows 7 operating system, which is 110, but I'm using I'll be using like 5 counts, 5 or let's say 6. Because I'm limiting the pinging to 6 only, and it's 5 seconds. So here it's pinging, it's actually working, it's pinging. Like here 6 packets are being transmitted and 6 has been received, so there's 0 packet loss, means the transmission has been completed. So now we'll be back again to the Windows 7. So I'll be pinging the Ubuntu IP address. So can see there's a reply, means both of them can exchange communication. So here the packet sent is 4, receive 4 packets, and means 0% loss, 100. So the transmission have been successful. And now I'll be changing the IP address to I'll be changing the IP address and see if and to test the I'm going to test it again, to ping it again. So it's 110. Let's say we put it 140. Let's say 140, and the Ubuntu one, we changing it to so let's see here, IPv4. I'm changing it to 150. So let's say clear. I'm just okay. Okay, it's for the Ubuntu one, I need to reset it until it just take the final the changes in the IP address. So I'm just rebooting Ubuntu, and for Windows 7, like here, Windows 7 110. So we change it to 192.168.56.140, which was previously 110. So now I'm going to ping both of them to see if to see how it works, even the IP address has been changed. So now after the IP has been changed, remember that the IP of the Ubuntu was 192.168.56.115. So after changing, should display it like here, 192.168.56.150. This has been changed, can clearly see. So now we are pinging the Windows 7 one, which is ending like 140. Go back to Ubuntu, ping 19, okay, minus C 6, count 6, 192.8.56.140, clearly pinging, so it's successful. 6 packets have been transmitted, 6 has been received, means transmission has been successful. Now I will try to ping the Ubuntu IP address from try to ping this one, this IP from the Windows 7. This is Windows 7, or yeah. So pinging these things. The 150 was a Ubuntu one. See, it's replying, means it's successful, and you can see that packet sent is 4, receives 4, 0% loss. So transmission, the pinging has been successful between the Ubuntu operating system and the Windows 7. So now, as a last part of the assignment, I'm going to show you how to transfer the file with the FTP server and how the client going to receive the file from the server. So here we open our browser. I'm going to open the server. FTP. So the authentication, username and password. So like here it's just been connected. This is the directory, the path. So like here, if we got in document folder, we got already 2 files here. So I'm going to add one more file. I'm going to write to save one file in that document. So let's say FTP connection is successful. Okay, I'm going to save this. Okay, I'm going to save in the document. This is the 2 document on the web server here. So I'm going to save this one. I'll put it like doc 1. I'm saving it. Okay. So let's just connect again to the file server. The file server which is on the Ubuntu operating system. Retail connect. So again, authentication is required, username, password. Say this is a directory, desktop, all these folders. So we're going to document folder, like here, which the last document I save is doc1, which I created just now, and these two were already present there. So now I'm going to go to the Windows 7 operating system using the client application to connect to the server, and then I will download these uploaded document. I will download this uploaded document from the file server. So let's go to Windows 7. Then this is a Windows 7 Oracle VirtualBox, and we are using the same IP address here, 115. This is the file server IP address. I'm accessing the file server. It requires the authentication. And that's good. We rarely connect to the file server, and this is the directories of the file server. So let's see if we really get to open the shared documents, the folder, all these documents here. So we're going to open the folder documents to download the file. See, so like here, like I told you, this file has been uploaded. So these are the free files that has been uploaded. Download, trying to download. See, the first one's downloaded. Second one is downloaded, and I'm downloading the third one. Okay. Okay, so are we opening all these three? So doc1, see, this is the file which I uploaded on the file server. This is the document, and the other one was named like K, and this is the FTP doc test. Yep, so I've been successfully downloaded. So the connection has been successful for the file server and client. So these are the free documents which I accessed from the file server. And this is the end. This is the end of the assignment part, and just we'll end the assignment with all the references we have been using. So I hope that I hope you did appreciate the assignment, and much consideration will be given. So these all the references that I've been using.